Hello everyone and welcome to Math Matra. Today in this video we will talk about the equation a minus b the whole square is equal to a square minus 2ab plus b square. Now we may have used this elementary equation for multiple time in past, but today we're going to talk about how can we go about proving the equation a minus b the whole square is equal to a square minus 2ab plus b square. So without further ado, let's get started. So we know a minus b the whole square. If you want to expand and come to a conclusion of a square minus 2ab plus b square, we can always go about multiplying a minus b times the a minus b, because a minus b square meaning that a minus b is getting multiplied by itself, right? So then we can expand the first bracket a and then multiply by a minus b the second bracket minus the b and multiply by the second bracket. Expansion further will take us to a square minus ab minus in parenthesis ba or ab minus the b square, and by simplifying further we will get a square minus ab minus ab plus the b square. Simplifying further, you'll see in here that you'll have minus a times b and minus a times b. You add them all together and it essentially becomes a square minus 2ab plus b square, right? So that's pretty straightforward and pretty simple. But today in this video I'm going to talk about one other way of proving. Now, beautiful thing about math is there are multiple ways of proving the same thing, right? But in this video we're going to talk about a visual proof. In my opinion, it's more convincing proof of a minus b square is equal to a square minus 2ab plus b square. The reason why I said more convincing is not necessarily these equations don't prove itself, but it actually gives you an idea how it works. So let's get started with a graphical representation of showing the proof in a graphical way. When I say graphical way, I should say more like a visual way with the shapes. So in order to prove visually the equation a minus b the whole square expands to a square minus 2ab plus b square, let's draw a line segment and call it a. Let's draw another line segment, call it b. So let's copy these lines down, rotate it 90 degrees. Now we have these lines rotated and let's label them a and b. Let's copy this line on the right. Now we have copied these lines on the right side. Let's copy these lines down as well, so make it square. As you can see, now we have a square with a blue color with the side of a length segment a, and the square with the brown color, light brown color, with the side of line segment b. So the area of the blue square is a square and area of the brown square, light brown square, is a b square, right? Now what do we want to do is we want to overlay these on one on top of another. So let's overlay this on top of another, and as you can see, the blue square and the brown square are aligning exactly at the left top corner. And since in our assumption line segment a was longer, as you can see, the blue square is projecting bigger or larger than the brown segment. Now, as we still know, this area of the blue square is a square and area of the brown square is a b square, right? Now what do we want to find out? We want to find out a minus b square. Okay, so let's put together the length of each line segment. As we already know, the line segment, the longer one is a and the smaller one is b, right? So let's put them down. With that, now we can easily tell the remaining line segment along b or the a side is a minus b, right? Because a is larger than the b, and whatever the segment remaining after line segment b is essentially becomes a minus b, right? So those line segments, let's label them as a minus b. Now a minus b square is essentially going to be at the right bottom corner, as you can see with the yellow square. That's the line segment we are trying to prove as a minus b square, right? That is the square, that is the area of the square on the left side of this equation a minus b square, right? So now let's find another way to calculate that area in terms of a square and b square. How can we go about that? Well, we know the blue square, which is the largest square, is a square, right? So let's start from the large square and deduct the area that is not important or intentionally we want to delete to get to the yellow square only. So once we deduct everything, essentially all we will have left would be the yellow square, right? So let's start with the blue square, which is the a square. Now we'll have to deduct the brown square, which is the b square, which is also known, right? So let's put a square minus b square. Now we still have to deduct two rectangular areas shown here with the green. As we can see, the length of each of the rectangle is a minus b and the width is b, right? So the area of each rectangle will be a minus b times b, right? Because the two sides of the rectangle is one is b and the other one is a minus b. So the area of the rectangle is the length times the width, right? So both of the green rectangle has the area of a minus b times b. So let's deduct those two areas as well. So the entire equation will now become a square minus b square minus a minus b times b minus a minus b times b, right? So now the two rectangle we can merge into simplifying it to a square minus b square minus 2 times b times a minus b, right? So now let's expand that. So once the expansion occurs, what we can come up with is a square minus b square minus 2 times b times a. So I'm gonna change it the way I write it and call it 2 times a times b because it's gonna be the same, right? So 2 times a times b and take the b inside, and that would be 2 times b square. But we have negative sign outside and negative sign inside, right? So negative, negative, positive. So it will be essentially b plus 2b square. So it will be a square minus b square minus 2ab plus 2b square, right? Now minus b square and plus 2b square. So it will essentially be plus b square. So now the answer will be a square minus 2ab plus b square. So that is the farthest expansion we can go, and after simplifying, that essentially will be our a minus b square. Graphically you can see that yellow square is the area that we were trying to come up from the bigger larger area of a square, right? So you'll have a square, then we deducted the brown square, and then we deducted two green rectangles, right? So then we came up with a smaller area which was remaining, and that essentially is the same as a minus b square. So now we are able to prove a minus b square is equal to a square minus 2ab plus b square. Easy, isn't it? And I hope you can see that how easy it is to prove a minus b square is equal to a square minus 2ab plus b square. And that is just one other way to prove graphically, visually. You can see how the area of a minus b square we can come up with by deducting all the other areas and simplifying the equation, and essentially becomes a square minus 2ab plus b square. So I hope you like this video, and if you want to watch more of these videos, please subscribe to our channel. Thank you. See you soon.